One thing that's very nice about Laplace transform is that it is a linear operator. A linear operator is particularly nice because if f and g are functions and c is a scalar or a number, then a linear operator behaves like this. Psi of c times f plus g is c times psi of f plus psi of g. And Laplace transform is indeed a linear operator. Yes, and you get why that's so cool, because if I want to find the Laplace transform of 1 plus 5t, I can say, well, that's the Laplace transform of 1 plus 5 times the Laplace transform of t. And we already worked those problems. Whoops. Here we found the Laplace transform of t. Here we found the Laplace transform of 1. So when we get to this problem, Laplace transform of 1 plus 5t is the Laplace transform of 1 plus 5 times the Laplace transform of t. So 1 over s plus 5 times 1 over s squared. The book has an error on this. In, oh, is it the 6th edition? It might be the 7th. I can't remember. But they have a little error in this particular problem. But hey, nobody's perfect. Don't worry about it. But you know, you'll have that. So there is a slight mistake there if you look at their example of, well, you know, that's just the way it is. You know, these things happen. Oh, anyway, some common Laplace transforms that we didn't prove all these. We sort of proved this one, and it's not hard to prove this one. Just do some partial fractions integrating. This one we already proved. This one we proved the special case where n equals 1. But if we wanted to find the Laplace transform of, let's say, t cubed, it would be 3 factorial over s to the 4th. And we already did this one. The Laplace transform of e to the kt is 1 over s minus k. The sinh, a hyperbolic sine, is this. That could be proven. Let's not say we did. Hyperbolic cosine, same thing. Look at the similarity between hyperbolic cosine and the cosine. See, the cosine has an s in the numerator, sine has a k in the numerator. Other than that, these two look very similar. Just like these two look very similar, except for the difference. So there's a sort of a table, if you want to call it that, for transforms for some common functions.